Thank you all for coming. I appreciate having such a crowd with such short notice. We had a cancellation, so I jumped at the chance to get another opportunity to preach at you. I'd like to say that I've only been, excuse all the presentation. I've only had, a few hours to put it together, but I've been working on this for a couple of years. So if it's bad, it's because it's bad. This is one of those talks that says you're doing it wrong, and that's a problem. It's a problematic way to do anything. I realize that. It happens to be my mode of learning, so hopefully don't take anything personally. I'll try not to be too preachy. Somehow I got made this way. I know there's no excuse for it, but I tend to learn by convincing myself of the things that I'm doing and that I love and that I think I do really well, and then convincing myself that I'm doing it wrong just to see if I can find something wrong with what I'm doing. So when I do this, it's not meant to do any harm to anybody except myself. The thrust of this talk is a number of points. One, a topic that I talked last year, same time, same room, same people. In fact, some of you, I think, are sitting exactly the same seats as you were last year, Evan. Is that TDD is still poorly understood and still poorly done. That automation is ruinous to productivity, contrary to our popular belief. Can be ruinous. The productivity that you get from design is vastly superior than the productivity you get from automation. And that TDD was supposed to be a path to greater mastery in design, but over the interceding years since 1999, 2000, it has become largely focused on tooling. So I want to talk about some fundamentals just to get things going. These are fundamentals about us, and by us I mean me, as I project myself onto you and believe that you are me and I am you. So this is my prejudice of the way I think that you work based on who I am. So I want to talk about things that are subtle and things that are crude as a model for cognition, learning, and mastery. Things that are subtle are things you might not yet be attuned to, things that you might dismiss out of hand. Often we use the term negligible, sometimes interchangeably or justifiably with things that are subtle, and sometimes out of a mistake for misunderstanding things that are subtle. Negligent things are things that you can afford to do without and not pay attention to. And I'll state quite audaciously that the things that are subtle are the things that you want to pay attention to, that you want to leverage. But they're very easy to miss and very easy to mistake as things that are negligible or things you can avoid. And then there's things that are crude, and these are just the vocabulary I'll use. Things that are tangible, things that are material. Crude would be at the opposite end of the spectrum of subtle for the purposes of this talk. Crude things are still a necessity. They're a starting point. They're the muscle memory, the drills, the dogma. And unfortunately, the crude things, the material things, are the things that we're hardwired to connect to. Our cognitive mechanism is hardwired to pay more attention to. This comes from the fact, I suspect, that we've spent more years as human beings trying to evade saber-toothed cats than evade software defects or design defects. They can be a trap, and they can be the things that get in the way of realizing the subtler things. The crude things are also the things that are easy to transfer. So I can probably teach you how to use a testing framework, but you're going to have to teach yourself how to design. This is one of the reasons why things like TDD end up devolving into what you might call, and I know this is a highly charged word, an intellectual materialism, which means you've got an idea of what you're doing, but then there's a cruder form of it that you're actually maybe doing. So I don't want to get anybody thrown by the term mastery here, because we live in a Western sort of industrial, modern culture. We tend to look at stuff like mastery with a sense of cynicism. We tend to look at things that are everyday and tangible, if we reached out and grabbed them, as mystical. We use the words like, oh, that's so zen, and zenning out, without actually having a fine understanding of what those things, for example, and perhaps having a more crude understanding of those things, and immediately blanket them over with cynicism rather than suspending disbelief and engaging with them. And the issue here I want to talk about mastery is the process, not the destination, which is more of an Eastern mindset of this. And you could also think in terms of perfection as the process rather than the destination. Once you transform it that way, you realize it's not this hoity-toity, flighty thing that's way out there. It's just the thing that is right in here, the thing that is every day, that is, in fact, something that becomes tangible. It's not meant to say that someone is a master. It's not meant to permit someone to claim that they are a master. It's merely a recognition of the process of improvement called mastery. And being in a pursuit of mastery is by no means an implicit license to claim that you are a master, unless, in fact, you have achieved mastery. How this connects to subtlety is that increasing advances you make in a skill, the first few steps you make are big and tangible. If you've never written a line of code in your life, then all of a sudden the next moment you've written a line of code. That's a big noticeable change. But successively the changes you make are less and less and less noticeable. At least they're less and less and less noticeable to someone who's never written a line of code, to someone who's been writing lines of code for 30 years. Those fineries, those advancements become ever, ever, ever finer. In fact, from the perspective of the right-hand side of this graph to the left-hand side of this graph, a personality on the right-hand side of the graph may say the last move on the left side is negligible, unnecessary, avoidable, unproductive. But when you plot productivity over this, you get an exponential increase in capabilities and ability and productivity as you make these finer and finer and finer adjustments to your understanding. These fine differentiations become so massively productive because these things that we're doing end up being pervasive. They're in every line of code you write, every class you write, every module you write, every product, everything that you do ends up getting this small refinement, which means in the large, it's not a small refinement at all. It's a powerful refinement. And this is the crux. Design is in the realm of the subtle. And test-driven development is a subtle thing. And test-first programming is a crude thing. And because crude things can be mistaken for subtle things, you can end up doing test-first programming without necessarily doing test-driven development. And now you have to sort of accept that what I'm saying, that I have some sort of authority over what test-driven development is. But I can say that after a number of years of practicing TDD, getting what I'm not a master at it, but pursuing mastery in it, less so than others, more so than others. It's possible to see code that was written test first and still end up with design qualities that are obviously, or can be seen as obviously undesirable or lesser. So test-first programming doesn't actually lead you to the lauded goals of test-driven development. And because of the way we're hardwired to see the crude things quicker and to be focused on them and have them steal our attention, you can actually have test-driven development in your mind, but have test-first programming in your hands and not really ever know the difference. Unless perhaps you would stop every now and then, look at your code and say, this is really going well, I'm doing good at this, I think I'm good at this. Wait, let me play a thought experiment that allows me to say, let me pretend for a minute that I'm not good at this, that I'm missing the point. and run that through your mind, and then take a look at your code through that lens, and you can actually start to use pessimism as a means of improvement, which might seem antithetical, but for a pessimist like me, it's quite essential. Let's talk quickly about automation. Automation is about tooling. Tooling is on the material side of the spectrum. Automation can draw your mind away from the design mind. It can draw your thinking away from the design mind. Here's a quintessential paper from an industrial psychologist that talks about automation. This paper discusses ways in which automation of industrial processes may expand rather than eliminate the problems with the human operator. This is something we've clearly seen with the prevalence of unit testing over the past decade and a half. The promise was if you write unit tests and a lot of unit tests, you get a lot of documentation, programmers will understand more of what they're doing. What tends to happen with automation is that we stop interacting with the code and we start relying on the automation. We become further and further and further separated from the systems that we're building, relying more and more and more on something else. But what we need to be doing as human operators is constantly be recharging our intimacy with the code base. And automation, though necessary for our works, also acts as a detractor from our ability to know the systems. What other industries, and I'd say this is one of the things that separates industry from craft, and suggests that software still lives in its craft state. Not that craftsmanship is bad, but craftsmanship combined with industry is better. This notion that we have yet to address, which is the realization that machinations aren't necessarily the answer, that automating everything that isn't nailed down isn't the answer. And I think one of the reasons that this is a problem specifically for us, even more than other industries that have come before, and why it's taking us so long to pay attention to this, is that we build automation. Our product, we are automation product developers. The last thing we are predisposed to hearing is that the main thrust of our lives is potentially not as helpful or as good as we like or need perhaps to tell ourselves. So it's been said for years, TDD is design. And when you talk to people about TDD, you can find someone doing test-first programming or test-driven development and see two very different things happening, or similar things happening, and two very different outcomes. And the difference here is understanding what kind of things are software design, and beyond that, what kind of software design characteristics are good characteristics, and why test-first programming leads you to design or desirable design. If you don't first start with some notion of desirable design, it's hard to get there. And if you don't start there, there's another thing you can do, which is become hypersensitive to any kind of friction whatsoever. To not think that these little frictions are negligible, but to say that all of these little frictions aren't normal. They're a sign of some looming, massive problem that is merely subtle. It's only subtle to your or my or anyone's level of ability right now. I may see something as subtle right now, but with years of practice, I'll know this to be a very large problem. Cancer is a very, very small piece of material, cellular, until it consumes the entire host. But each individual cell doesn't get larger. The problem just becomes pervasive. The same token, small things, small benefits have the same impact on the other side of the spectrum. So, let's talk about good design. And this isn't enough time, there isn't enough time in the world, there might not be enough time in one human lifetime to really cover what is good design. So I'll talk about a few things that are a good starting place. Encapsulation, coupling, and abstraction are, you can consider these design principles, just as you can consider more tangible or more concrete design principles like separation of concerns and inversion of dependencies, and principles like lift-off rules like Liskov, I should say. These are more fundamental higher order: encapsulation, coupling, and abstraction. And of course, you could go on and say there's also, you should be considering complexity in here. Encapsulation is about, well, there's a good rule of thumb: tell, don't ask. That means tell objects or systems what to do, but don't ask them for things. Coupling is how many lines of entanglement exist between two modules. Where a module, I don't mean a Ruby module, but anything that is a unit of decomposition of software. In Ruby, it would be a class. It can be a module. In a functional programming language, it would be another construct. With weaker encapsulation comes more coupling. Abstraction sort of hovers around these things. This is knowing what boxes to put things in. Where a method goes in one place or another place, or that you need a whole other thing to put stuff in. And the purpose of all of this, really, a computer will run a mess just as easily it will run something clean, right? A computer was invented to follow your instructions. Like, there's no other reason that this machine exists but to follow your instructions. It's really no great accomplishment to be able to get a computer to do what you tell it to do. That's the only reason it's ever existed. The whole reason for this is human. This is so human beings can have clarity over the code, over the design. Design is about human cognition. We are shaping software not only the way we have to shape networks and deal with the principles of distributed computing, but also for human cognition, because this is the thing that is the predictor of productivity rather than automation. And it turns out that we massively underestimate, on average, the impact of design mistakes. We look at design mistakes that are subtle as negligible. And the reality is, any sense of frustration or friction that you feel is a sign that the cancer is in you already, and it's time to deal with it right now. It's not negligible. You can't wait. This is what these design principles that seem so esoteric, if you read them on Wikipedia, seem so academic. Why would somebody pay attention to them? The reason is that if you only look at individual issues in the small, well, all of those things can be seen as negligible. Once you start to see them as pervasive, as patterns that are pervasive, you'll understand that the rot is there. The reality is that your productivity can be massively increased by focusing on design principles, because you free yourself from the downtime, the pervasive downtime of figuring things out. Here's a nice, dirty little secret that you should think about before you go to sleep. Every test is an additional coupling. So how do you get greater productivity? By adding more coupling. But how do you get away without testing? I mean, I'm not saying that you should just go ahead and delete all your tests unless they suck. And then you might just want to rewrite them. But every day, this is an unavoidable consequence. And this is the downside of this. The poorer your design, i.e. the less clarity you have, you're going to start falling back on more and more testing. The more and more testing you have, the more coupling you have. The more coupling you have, the harder it is to change your stuff to make it into something else that's more clear. It's a vicious circle. It's a downward spiral. And this is the other downside of this. Every single test framework available to you naturally encourages you to violate the productive principles or the principles of design that give you this productivity. As an aside, a lot of the syntaxes, the grammars of the frameworks are obstructions to the creative flow of test-driven development. And the goal here is to start focusing on, in terms of design, is to start focusing on things that are workable, rather than things that are just working. Working software is necessary, of course, but it's the low end. It's the bar, it's the lowest. I don't know how to say that. Well, it's not as good. Let's just leave it at that. You can have good, but better is better. And workable means you can sit down with it. I wasn't there for the talk yesterday, but I think somebody on a panel said the only measure of software quality is WTFs per minute. Is that right? Is that what somebody said? That's the same thing. That's workable software. It means a human being can work it. We think it's normal to sit down in software and be stumped. Sit down with code and be stumped. It's not normal. It's completely abnormal. It's actually a sign of our industrial immaturity. Probably not really immaturity. I call it primitiveness or craft. A craftsman can probably create amazing things. And those apprentices in his shop can probably work the way he does. But perhaps a craftsman from one side of the country to another side of the country, maybe their people couldn't work with each other's systems, even if they were both building chairs of the same wood with the same tools. That's the difference between workable. It's a matter of industrial process. It's a matter of looking at knowledge transfer as a means of momentum transfer. And we typically have sawtooth development processes where you do some work and you build up all this momentum and you hand it off to the next person in the process, and the momentum drops, and it drops because they got to sit down and figure out, decipher. And we tend to pride ourselves on this ability to decipher code, where it's a great thing to have if that's your crisis. You know, if your house is burning down, it's nice to have firemen. It's better to not have your house burned down. It's wonderful to be able to solve these intractable problems. Even better, figuring out how to avoid them. I'm not a really good debugger. I find myself at a loss in this business because I'm not really good with working with other people's code. I've spent more of my time figuring out, teasing my mind and torturing myself on how to avoid having to decipher code because I find it so frustrating to spend time that way. So I want to take some inspiration from service-oriented architecture to talk about design. And here's where we're going to start to throw out even more, perhaps countercultural ideas. And we'll work this back to objects. So we'll start with services. This might be, hopefully this is a little bit of a psychic shock. Services never return data. Services only accept commands. Services may respond with signals that give their status. It's impossible to have a software construct called a service that you can ask, give me the last orders from the last 10 minutes. That is, in fact, not a service. Well, from the perspective of SOA. What we tend to have, what we call services, are actually databases with HTTP interfaces, which is a perfectly fine thing. How we get this way is another example of the process of materialism and attachment. Those things used to be called web services, but somebody said F, enterprise, at some point, and so things that were associated with web services or enterprise were no longer viable or valuable or culturally conducive to our careers. So we dropped the web off the front, we started calling them services, and now we've created confusion or even an obstruction to an even deeper, subtler field of knowledge. Web services are perfectly fine. We should probably just call them web services. In fact, we're so embarrassed about saying that we use web services, we now call them APIs. If you think about this in terms of objects, or what you can do with objects, it becomes difficult to get your head around if you've been steeped in active record. Because active record violates many of these rules that help us keep our systems productive. Order.person.address.street is not a good thing to do. That's a violation of encapsulation. Active Record is a fantastic set of shortcuts that is incredibly valuable to us as workers and incredibly valuable to our society who needs software on a short timeline. But it's a set of shortcuts, and we use these shortcuts specifically because we know what we're getting ourselves into. If you believe, as Dave Thomas intimated yesterday, that there's an architecture there, or that there's a good architecture there, because it's the only thing you've seen, then there's more to be seen. So I'm running out of time. I want to jump to code. So I want to talk about flow in TDD. So I've got an idea for a sample app, and this is very, very trivial and very naive, mostly because, oh, you don't see this, do you? What do you think? It's my new programming language. I call it boats. Except I can't see my screen. So I want to just do a really quick, very, very naive. Unfortunately, this is such a trivial example that it might not highlight TDD very well, or this hypothetical, theoretical testing framework or testing library. And I'm not going to show you this to say, hey, everybody jump on the bandwagon, use my framework. This is not a framework. It's a proof of concept, just to talk about what might happen, what you might do to restore a design focus to test-driven development, maybe as a rehabilitative mechanism. I'm not saying stop using test unit or stop using RSpec. So this little example is about, I'm sorry, I've really got to figure out how to mirror my screens here. Okay.
It's in your display preferences.
I think I accidentally just made it happen. That's awesome. You have voice command over my computer. That's not just a little disconcerting. So the sample is going to be string reversal. Ooh, I've got old code in here. My bad. Let's just do the old. Let's just do this dirty. RM-RF is always a great thing to be typing when you're doing live coding. Excellent. I think. Let's find out. So I just want to write a quick string reverser, and I just want to do it with a little bit of TDD. So this is a library called proof, gem install proof, if you want to tinker with it. It's not a full-blown library. It's very primitive. It's meant to be primitive. There's no runner. I didn't want a runner. I wanted to be able to run this with Ruby. I wanted to be able to run it from the command line. I didn't want to have to install an editor plugin for anything. Very, very, very primitive. What I mean by primitive is that there's not so much automation that I no longer pay attention to the code, that I remain intimate because the automation isn't keeping me away from it. So I like to do a thing that I call, let me see. And I'm also using a sort of folder structure here that is just straight up what Ruby gems tend to be. Trying to figure out like what files go where and all that stuff. That's what I mean about getting in the way of the flow. Figuring out whether you've got a context or a specification or an it or a do or those things. How deep of levels, whether something is a let or an instantiation. That's all good and well and good. I just found that started getting in the way. So I tend to do things called sketching, which isn't anything that you can't do with any other framework or any piece of code. I just stopped starting with a test. I don't start with a test framework anymore. I really just do the TDD thing. If I'm going to do like a, I'll have some throw. Okay, I've done Java, all right? All right, fine. So that, to me, is a perfectly fine way of getting away from the framework and getting into the flow. I didn't start with figuring out whether I've got a context or specification. I'm really more concerned with the file name, that kind of stuff. I'm just calling it sketch for now. But I'll do all kinds of this stuff, and I'll just sketch it. And I've done this with teams on projectors. We just bang out some stuff, and then from here start to move it forward. And I'm going to have to go to the ready-baked turkey, because I've got, am I over time, or I've got 5 minutes? Anybody know? I'm going into lunch, right? So this was like last year, we went into lunch. The thing that I want to do is help you not stand in line, and that's why I've made this take longer. So again, this is pretty trivial. It's a really naive example. I mean, I wouldn't say this is a thing that maybe even needs test-driven development. But this is a really simple example of what the premise of TDD is: to think through your code first, think through your design, think through the API, write it down, even though you don't have any code. And I'm not using a test framework here. I'm just saying raise, if, blah, blah, blah. You know, from here, just to get my thoughts clear, I don't really have to do anything more than create a class and start implementing. And I'm not going to do red green refactor. I'm not going to do this. I'm not going to do this to the book, by the book. The goal here is not to show TDD. Oh, or to spell it init EL. What I'm trying to do is not put on the reading glasses that I've been prescribed to use since the last time I spoke at this conference, so damn you. Oh, yeah, I knew that. This James messed me up yesterday with the splat, and I had a nightmare about it last night. A splat without arguments. Now all of a sudden everything is screwed up. Thank you. Text, and then I could say at text.reverse. Right? Didn't raise. I want to do it the other way, just to say that this is a pass. Obviously, this wouldn't be very helpful. But you're getting the idea. I'm just saying we can start banging some things together, move things into where they belong. Etc. But this isn't the point of the proof framework. The proof framework is about, or the proof library, I hate to call it a framework, is about saying, well, let's say, where would you say the violation of encapsulation is in these 3 lines of code? And again, it's a trivial example, so you got to sort of bear with me and don't apply this mindlessly. This is it. I said services don't export their data. They accept commands. But all of our test frameworks usually say assert that person.fullname equals, and then you've got some other thing, like some value. If you're pulling things off of objects, you're exposing a greater surface for coupling. You say, well, how would you do that? How could you put active record objects on a screen if you couldn't do that? Well, there are other patterns to do it, and in the case of active record, it may not make sense because you're talking actually at that point about data structures. And TDD over data structures is usually not terribly helpful anyway, especially data structures that are already based on a framework that lock you in to it's basically paint by numbers at that point. In fact, TDD with Rails may not even be as valuable. It's valuable, but only for the things that you're inventing. It's valuable when you look at Rails as the 20% of your solution rather than the 80% of your solution. Because you're not creating things. Test-first programming can help you think through things, but you're not really thinking through a lot of complexity or design, coupling, all these other problems. All those things have already been set in stone for you by the framework. So how would I deal with a testing framework that didn't allow me to disencapsulate? Following tell, don't ask. So I'll just jump to the ready-baked solution, and we'll be real quick about it. Oh, I love Git, especially when I'm stressed. All right, let's do this. I've had a lot of luck with this live coding. This is great. Usually I just delete my hard drive.
Keep running RMRF. It's got to pay off.
The presence of RMRF in my console and your voice at the same time are probably the conditions that have to come together. With your voice commands and my clumsy fingers. All right. This is what a test looks like using proof. And proof is really just a proof of concept. That line 7 is the thing that is allowing encapsulation to not be violated. It would be fantastic if it ran. Great. Not a lot of fanciness in the output. The idea here is I kind of tend to like to force myself to read the output. What I noticed a lot over the years, interceding years, is I'll run tests and not look. So I actually don't, if I'm just running a file, the great thing sometimes about, well, some of the great things about RSpec is you'll get actually like a summary of errors. I don't get a summary of errors. I scan the output, which forces me to have a lot smaller files with a lot less test content. And the difference here, the key difference, and the thing that I think that I like to do, and what I found helps me even more as somebody who thinks they can design quite well, by moving tests out of, by not encouraging encapsulation, I've found that a key thing that you tend to see with test-driven development a lot, you'll find code that you're using only for the test starts to make sense for the actual production code. And if you're not seeing that every now and then, you're probably working with a framework, and that framework gives you blanks to fill in where you're not really discovering design. But often, when you're not working with constraints and you've got to work through things on your own, you're building something new, you'll find that you've got code that is in the test but seems to be germane to the object or the class or the module you're working with. So this is how proof works. You put a module in a namespace. This module of the class you're testing. This module is called proof. And when that line 7 is executed, actually when line 5 is executed, I monkey patch object, which everybody knows is perfectly fine. At least I'm not monkey patching kernel. Oh, no, that might be the right way. No, I'm just kidding. So I monkey patch object. My apologies. Add the proof method. When the proof method is executed, it looks for an inner module called proof inside the thing you're testing, extends the thing you're testing by that, and avails for you these methods. And the critical thing about these methods is not to do something like this. which does work. Does work. However, by doing this, you're not exploring the encapsulation. You're dealing with primitives. You're dealing not with the object interface or the abstraction. You're pulling things out of the abstraction, increasing the coupling surface. And I'll say it again, although that seems like a really, really negligible thing, after 2 years and you find yourself in this productivity grind, the reason for that is believing that every instance of disencapsulation, all million of them individually are irrelevant, rather than saying the million of them are in aggregate or why this project sucks now. And it's usually not 2 years, it's usually 2 months. That's all I have. Thank you for listening to me preach.